Hello everyone, welcome back to this channel. So in this video, we're going to look into chapter 3 of IGCSE Math, Algebra Basic. So this is the chapter outlined. So in this subchapter, we're going to look into what a variable is, how letters can represent different values, what an algebraic expression is, and how do we write an algebraic expression from real life scenario. We also will know the convention of writing this expression. And after that, we'll briefly explain how algebraic expression links to formula and equations. So first of all, what is a variable? A variable is a letter used to represent an unknown or changeable numbers. For example, if I were to say that x is equal to 4, then 2x will be equal to 8 because 2 multiplied by 4, it is equal to 8. Whereas if x is equal to 10, then for example, 3x can be 30. So x can take in different values, it varies, and that's why we call it a variable. In fact, a variable doesn't even have to be x. It can even be y, z, a or b, any letters. So understanding what a variable is helps us to understand what algebra is as well, because in algebra, it contains variable. Algebra is used in many real-life situations and across different science subjects. For example, in physics, you have this formula for speed, and they utilize different variables to represent different quantities. For example, v here is velocity, d is distance, and t stands for time. Same goes to biology. You have the formula for BMI that is an expression of algebra and that they have variable in the equation. And also in chemistry, this is the equation for gas laws. So this is how algebra is applied in everyday life. And in this syllabus, you are going to see a lot of something called the algebraic expression. An algebraic expression is a combination of numbers, variable, so it can be any letters x or y here, and also the mathematical operations. And one very important skill that you need is to translate words into algebraic expression. For example, how do we write an algebraic expression for the sum of a number and 13? So this number here, it can be any number. That's why we can represent it using a variable. So for example, I could do m because it's the sum of the number and 13. So I'm going to have the operator and also the number. So in this case, we have an example of an algebraic expression. Well, second example, 10 times the number. Let's use x instead. So x is the variable, and 10 times of it, you just multiply by 10. That's why we have 10x. So the next one, the unknown number cube. Again, we can use any character to represent it. So I'm going to use y and cube it. That's my expression. The number means 1 over 3 of the number z, then plus 3. So this is a more beautiful version of what I've just written. Again, it doesn't matter what character you use because it is an unknown. So before we dive into substitution and look into the equation, there are a few rules that you have to obey when you're writing your own algebraic expression. For example, say you want to do 2 multiplied by an unknown variable. Instead of writing 2 times y in your equation, you can just write 2y. You do not have to include the multiply sign, right? That's the first rule. Second rule is that you also do not need to write 1 in front of a variable. So instead of 1k, you can just leave your expression as k. Well, thirdly, the convention when writing algebraic expression is to write the coefficient, which is the number here, before the variable. So instead of z2, like it means the same thing, z times 2. But in algebraic expression, we'll write 2z instead. And the fourth rule is to use powers for repeated multiplication. So if you want to represent x multiplied by x in this scenario, instead of writing it this way, you could just write it in x to the power of 2. That represents x multiplied by x. So next up, for the fifth rule, when you're dividing a variable, instead of writing the division sign, in your algebraic expression, you have to write it in fraction form. And the sixth rule is that power only applies to the letter or numbers immediately before them. What do I mean by that? Say you have this variable called 3x squared. So the square here only belongs to x, but not 3, x to the power of 2. All right. But what if you want to say, I want this power of 2 to belong to this coefficient 2? That's when you need to put a bracket, which is rule number 7. Powers outside bracket apply to everything inside. So if you have 3x, but you have a bracket instead, before you put the power of 2, that's when the power of 2 is applied to both the coefficient, which is 3, and also the variable, which is x, which you have 3 squared x squared, which is 9x squared. So the rule is that when a power is outside bracket, it affects the whole bracket. Well, having learned the rules of algebraic expression, now let's try to construct an expression from scenarios. So the person's age in 5 years. So we know that the current age is A. So in 5 years, the age will be A plus 5. And the third example, the person's sister is twice as old. So if the person's age is A and if the sister's age is twice as old, so we're going to have 2 multiplied by A. Again, you do not need the multiplied sign as explained by the rule just now. All right, now let's solve some quick question. How do we simplify 2yy? So yy here it basically means y multiplied by y. So we can do y to the power of 2, 2y squared. And another question, let the cost of a pen be P and a pencil be $3 less. At this point, I can write pen is equal to P, that's the price. And pencil, that's $3 less than pen. So it's going to be P minus 3. So the price of 2 pen is going to be 2P, 2 multiplied by P, plus the price of a pencil will be P minus 3. And what we can do next is to add up the like terms, 2P plus P minus 3. That will be 3P minus 3. I'm going to teach you how to simplify like terms in just a bit. This is just an example. Well, hard question. A square has side S. Write an expression for the total length of 3 such squares placed side by side. So if I have 3 such squares placed side by side, it's going to look like this. And they all have side length S. So we have to find out the total length of 3 such squares. And the total length is going to be S plus S plus S. So what I can do here is to add them all up. So that's when we have 3. So the beautiful version, this is how I solve the question. Well, the second topic of this video is substitution. So we'll learn what substitution means in algebra, and then we'll evaluate algebraic expression by substituting these values, and then we can form expression from word problems and calculate their values. Now let's look into what substitution is. In algebra, we know that letters represent an unknown number. So substitution means replacing the letter with a number. For example, in this case, a taxi company charges $5 plus 2x. And x here is a variable and represent the number of kilometers traveled. So if a journey is 10 kilometers, we will substitute x to be 10. So we know the starting price is $5 plus 2x, but then x here, because it's the number of kilometers traveled, we can just substitute the value of 10 into it, where we're going to have 5 plus 2 multiplied by 10, which is 20. So in other words, the fares will be 25. So this is the better version, and it also shows you how we do substitution. Basically just replace the variable with a number. So to just formally introduce to you the terms in algebra, we have a variable, expression, and substitution. So a variable, already mentioned, a letter that represents an unknown number. Expression is this entire expression here. And substitution happens when we replace the variable with a given number. Now let's try to solve some question. Find the value of each expression when x is equal to 5. So the first expression, 4x, we substitute 5 into the equation will give us 4 multiplied by 5, which will give me 20. And the second example, x plus 7 is the expression. Substitute 5 into x will be 5 plus 7, which will give me 12. And last example, 10 minus x, it will be 10 minus 5, which will give me 5. So this is the answer, and that's how substitution works. It's not very difficult. So work example 2, when you have multiple variables, they say find the value of 2a plus 3b when a is equal to 4 and b is equal to 6. So again, I'll rewrite the expression is equal to 2 multiplied by 4, 2a plus 3, b is 6. I'm going to put it into the equation, which will give me 2 times 4, 8 plus 18, which will give me 26. So that's the solution. For example 3, that's when we have to start creating our expression. A concert ticket costs $12 and each snack costs $3. If x is the number of snacks bought, which is the variable, write an expression for the total cost and find the cost when x is equal to 5. So first of all, let's write our expression. We know that the ticket price is something you have to pay, which is $12. What is variable and what varies is the number of snacks you bought. So each snack costs $3. So you're going to write 3 multiplied by the number of snacks, which will be x here. So this is the expression of how much we have to spend. But the question also said, find the cost when x is equal to 5. So in this scenario, I'm going to substitute 5 into my equation, which will give me 12 plus 15 and give me 27. And that is the total cost. Well, now let's solve some quick question. Evaluate 3a plus b when a is equal to this, b equal to this. So write the equation and then substitute 2 into a and substitute 5 into b, and then perform the multiplication and then add up to get the final answer, 26. So medium question, a t-shirt costs $8 and a hoodie costs $25. So that's $8, that's 25. Write an expression for the total cost of X t-shirt and Y hoodies. So if I were to buy X amount of t-shirt, the price will be 8 multiplied by the number of t-shirt, which is the X, plus the number of hoodies that I bought. So hoodies is $25, multiplied by the number of hoodies, which is represented by the variable Y. That will give me 8X plus 25Y. And that's my expression. So find the total cost when X equal to 3, which means you buy 3 t-shirts, and Y equal to 2, which means you buy 2. So that will give me 8, substitute 3 into X, plus 25, substitute 2 into Y, which will give me 24 plus 50, and the answer is 74. So this is the expression, followed by the evaluation of the expression after we substitute the values. Well, that's it for substitution. In the next part of the video, we're going to look into how to simplify expressions. So we'll understand the following terms called term, coefficient, constant, and recognize fractions and expression with operator can represent one single term. And we'll also learn what like terms are. And after that, we will simplify our expression to make it more readable. So another definition, we know that this entire thing is an expression. So what is between each operator is what we call term. So in this expression here, we have 3 terms, 4x, 3y, and 5. So the next term is coefficient. That is the number multiplying the variable. So in this case here, 4x and 3y, the number 4 and the number 3 are what we call coefficient. Next up, we also have constant in our expression. A constant is just a number on its own without a variable. So one thing you have to take notes when reading algebraic expression is that fraction represent one term, even if it has an operation inside. So for example, 3x divided by 2, it is one term, but 5y minus 2 divided by 3 is also one term. And the reason for this is because if you know the value of variable y, for example, in this case, this entire expression will be evaluated to one number, which is why we call this one term, because eventually it will just be evaluated into a fraction. So the tips to know when is it considered a term is when, as long as there is no plus or minus outside the fraction, then it will count as one term. So now you have understood the definition of term, coefficient, and constant. It's now important to know what like terms is because they help you in simplifying your algebraic expression. So like terms are terms that have the same variable, the same power on those variables. The order of the variable does not matter. So what do I mean by that? Example of like terms would be, for example, 2x and 3x. They have the same variable, and at the same time, the power of these variables are the same. So another example, 5y squared and 3y squared. So both terms here, they are called like terms because they have the same variable, and then the power of this variable stay the same. So let me give you an example when a pair of terms, they are not like terms. For example, 2x and 3y. So they are not like terms because, first of all, they're variable. They are not the same. So similarly, if you have 3z squared and 9z cubed. So even though their variables are the same, but because the power of these variables are not the same, that's why they are not considered like terms. So in here, I have many others to show you what like terms is. So you can see that 4ab and minus 2ba, they are like terms, even though they don't appear to be the same, because in this rule, the order of the variable does not matter, because you can always rearrange minus 2ba to be minus 2ab. They are the same things. So some work example, identifying like terms. So in this scenario, step 1 is to look for terms with the same variables and power. So I have 6a here, so I just have to find out the term which have the variable a, which will give me 4a and a. So we say that these trees, they are like term. So the second term, we have minus 2b. So I just have to find out the other term that has the variable b, which is in this case. So these two are considered like terms. So a more beautiful version showing you which are the like terms and which are not. So one reason we have to identify like terms is because like terms can be simplified. For example, 5x and 7x, they are like terms, which means we can simplify them into just one term. So for example, I can do 5x plus 7x and simplify them into 12x because they mean the same thing. So another example, 9y minus 3y would give me 6y. So it's just like 9 minus 3, but then now you have a variable. So another example here that has multiple variables. So what I will do is that I will rearrange them so that I can see them properly. And after that, I'll just simplify the like terms together. 4a minus 3a will give me a plus 2b. So this is how I would do it. So when you're adding or subtracting terms together, they have to be like terms. But when it comes to multiplying and dividing, you do not need the two terms to be like terms. So these are the two steps that you have to do when you simplify by multiplying terms. First, you'll multiply the coefficient and then multiply the variable using index rule. So what do I mean by that? First, you'll multiply the coefficient, which is 3 times 4. So remember, the coefficient is just the number beside the variable. And then you will do another part, x squared multiplied by x. So we know, so 3 times 4 is simple, it's just 12. But how do we deal with x squared multiplied by x? Remember, in index rule, we said that if the basis of two terms are the same and we are multiplying them, we can just add up the power. So in this case, we can just do x2. So this is power of 1. Because they are multiplying, I can just add up their power together, which will give me the final answer of 12x to the power of 3. And that's how I simplify by multiplying terms. So this is a more beautiful version. First of all, I multiply the coefficient. Second, I add up the power of the variable because I'm multiplying them. So another example here, 5y multiplied by 2z. Now we have two terms that have different variables. So in this case, coefficient multiplied by coefficient multiplied by y multiplied by z, which cannot be simplified further. So which will give me 10yz. And this is how I do it. So dividing is the same. 10xy divided by 5x, I will divide the coefficient first, followed by the variable. So 10 divided by 5, and then xy divided by x. So what I can do here is that 10 divided by 5 will give me 2. And x here, because they're appearing in both the numerator and the denominator, I can just cancel them out, which will give me the answer 2y. So this expression here, they can be simplified into 2y. And that's the power of simplification. So that's another way to see why I can cancel the x out. Well, a challenge problem for you to solve. So in this case, I have a fraction, and on the numerator part, there is an operation going on. So there are multiple ways to solve it, but I will always try to solve the operations on the fraction first. For example, I will do the numerator part, 4a squared b multiplied by 6b squared c. So I will do multiplication of the coefficient, and a squared remain the same. B will be b multiplied by b squared. So there will be 1 plus 2, and c is just a standalone itself, divided by 8ab squared cubed. So if I were to simplify it, I'm gonna get 24a squared b 3 c 8ab cubed, right? So now you can see that the top part has been simplified. So I can just use the division method that I learned just now. 24 divided by 8 will be 3a squared divided by a. We know that in division rule of index law, I can do this, a2 minus 1, so I can just cancel this out. And then I'm going to have a on b cubed, they are the same, so I can cancel them out, no need, and followed by c, standalone. So the final answer will be 3ac. So this is a beautiful version to show you how I simplify each term together. Alright, next up, let's solve some quick question. So easy question. Simplify this expression, 8m minus 3m is one, they are a pair of like terms. 2m plus n, they are another pair of like terms. So I'm going to have 8m minus 3m, 5m, and 2m plus n will be 3n. So this is the final answers. Next up, we have 3ab multiplied 4ac times 2. Again, this is multiplication. Again, I will multiply all the coefficients 3 times 4 times 2, which will give me 24. And a multiplied by a, which will give me a squared. B multiplied by nothing, stay. C, stay. So this is how I do the multiplication. Alright, now we have learned how to simplify algebraic expression. There is another thing in an algebraic expression called the brackets that you sometimes have to deal with. So in the next part of the video, we're going to look into what brackets mean in algebraic expression. So when you're dealing with algebraic expression, there are times when you need to do something called expanding the bracket, which means that you have to remove the bracket. So what does expanding mean? Expanding a bracket means you are multiplying the term outside the bracket by everything. So in this example, a bracket b plus c, it means that I'm multiplying a to b, and I'm also multiplying a to c, which will give me ab plus ac. So let me give you some example. So in this algebraic expression, I have 3 bracket x plus 4. So I'm going to multiply 3 times x to expand the bracket, and 3 times 4, so which will give me 3x, 3 times 4, 12. So that's how you remove the bracket in an algebraic expression. So 3 times x, 3 times 4, 3x plus 12. So the next quick example involves your skill in expanding the bracket and simplifying, because there are times after expansion you have to simplify it. For example, 3x plus 2 bracket x plus 4. So we know that bracket means 2 times x and 2 times 4. So to write it out, it will be 3x plus 2x plus 8. So you can see that after expanding, this is still not the simplified form. So what I can do here is to simplify 3x plus 2x, because they are like terms, into 5x plus 8. So that's how you can simplify it. First you expand, and then you simplify. So it is also important to watch out for negative sign. What if you have negative 3 bracket 9 times 4? So we know negative 3 times y, that's easy, that's negative 3y. But what happens when you have negative 3 multiplied by negative 4? Remember, when you're multiplying two negative numbers together, the result is always positive. So we know that the value is 12, but the sign here will be positive. So this is an explanation. Negative 3 times y, negative times positive, you get negative. But then when you're multiplying negative with negative, you get positive. So now let's solve some question. Solve. So 7 multiplied by t plus 1, you have 7t plus 7. And the next question, expand first, then you multiply. So you have 2x plus expansion 3 times x, 3 times 5, 15. We're going to have 5x plus 15. So another question which involves negative number, 3x minus 2 times x, which will be minus 2x, and minus 2 times minus 5, which will be negative multiplied by negative, positive. So it will be 5x, which will be x plus 10, which is stated in this answer here. Well, for the last part of the video, we're going to look into indices with algebra. If you have been watching my video on the index law, this chapter should be very easy to you. So just a bit of recap, index notation. An index tells us how many times to multiply the base by itself. So if I have 4 to the power of 3, it means 4 times 4 times 4. So here are just some rules on index law. Remember, when we are multiplying terms that have the same base, we just added up their indices. So with that knowledge, we can solve x power 4 multiplied by x power of 3. That will give me x 4 plus 3, which will be x power of 7. And as for division, everything is the same, except that instead of adding up the indices, you are subtracting it. So 9 to the power of 7 divided by 9 to the power of 2 with 7 minus 2, which will be 5. So this is the more beautiful version. So law number 3 say the power of the power. So if you want to multiply the power, you can just put a bracket and then put a power inside. For example, z to the power of 2 bracket to the power of 3. That's when you have z 2 times 3. And next up, 0 power, whatever the base is, it will be evaluated to 1. So in this case, z to the power of 0. Even though I don't know what z is, it's an unknown, but I know whatever it is, it will be evaluated into 1. And negative indices, so this is the law. If you have this negative, if you remember what I taught, I just turn this negative into 1 over and then put whatever index is at the bottom. So in this case, x to the power of negative 3. This negative sign here, I do it translated into 1 over, followed by x to the power of 3. So that's how I express negative indices into fraction. That's the answer. Alright, another rule for index law is the fractional indices when the numerator is 1. So in this case, we know this is the rule. express y to the power of 1 over 2 as a square root. So you can just do square root y. So last rule for index law, that's when you have fractional indices, but the numerator is not 1. That's the rule. And express d to the power of 3 over 4 as a root. So I know I can do d to the power of 3 and then have a root of 4. That's the rule. So that's how I solve it. Now, before we end this video, let's try to solve some quick question using the law we learned. So simplify this expression. Again, what I would do is to multiply the coefficient together and then simplify the variable using index law. So for example, starting from x, so I have x to the power of 2. We are multiplying, so we'll add up the power plus 3 and y to the power of 4 plus 1, which will give me x to the power of 5 and y to the power of 5. So this is a more beautiful version of how I solve it. So the next question here is involve division. So again, I'm going to do the coefficient first, 8 over 4, and then multiply by a6 divided by a2, multiply b4 divided by b. So we know that in division, we just subtract the indices. So 8 divided by 4, I got 2, and then followed by a4, 6 minus 2, 4, and then b3. So that's the final answer. This is a more beautiful version, so you can see how I minus out the answers. So some medium question here involve using the multiplication rule. So I have this fraction. Again, this is just one term. So I'm going to solve the numerator part first. So 2a to the power of negative 2, and then you have bracket for power of 3. So remember, the power here applies to all the terms in the expression. So I'm going to have 2 to the power of 3 and a minus 2 times 3. That's multiplication. And 4a minus 1. So again, even though it looks complicated, I can always use the index law. First of all, I will deal with the coefficient. 2 to the power of 3 is 8. 8 divided by 4. And then a. And as for a, the power is negative 6 at the top. What is on? Because I'm dividing what is in the denominator, I'll just do minus 1. And with that, my answer will be 2 and a negative 6 plus 1, which will give me 2a to the power of negative 5. So if I want to express it in fraction form, I can put this negative into 1 over and 2a 5. So if I want to express this into fractional form, this is what I can do. I just move a to the bottom. All right, here's some hard question. So in this example here, we have fractional indices. So again, since I have a bracket, I'm going to multiply 2 into the power of both x and y, which will give me x to the power of 3 over 2 multiplied by 2 and y to the power of negative 1 over 2 multiplied by 2. So after I simplified it, I will have x to the power of 3 and y to the power of negative 1. And to show you a more beautiful version, this is what I have done and then simplified it. If you want to further simplify it, you can even put it down because y to the power of negative 1 is 1 over y. So you can just put x to the power of 3 on top. And that's about it for algebraic expression. Thank you so much for watching. I will see you in the next video. Goodbye.